make sure I've turned my own phone off.
So, everyone, it is 6 o'clock, so welcome to the Quarry Whitehouse auditorium, to our audience here tonight. Very pleased to see some Wolfson members here, as well as the Selwyn crowd. And also, we have over 100 people joining us online, so you're also very welcome indeed. And a particular welcome, of course, to our special guest, Professor Jane Clarke, who is a distinguished biophysical scientist. She's a Fellow of the Royal Society and President of Wolfson College, Cambridge. And we'll talk about the science, but also her highly unusual career, in which the headline is that she didn't start her PhD until she was 40. So that rather challenges the conventions about what a career in science and science research is like. We will be taking questions from the audience in the auditorium, but also from people at home. So you're very welcome to send questions to master@sel.cam.ac.uk. I'll just repeat that, master@sel.cam.ac.uk. So we'll come to questions in a few minutes. But Jane, I want to ask, you may have spotted I'm not a scientist. So I want to ask you one or two basic questions about science. So you work with proteins. What are proteins?
Okay. So I would argue that proteins are the most important molecules in the body. I mean, DNA people might disagree, but actually they're wrong. And that's because proteins are the molecules that do everything. They're the toolkit of the cell. So any function that the cell does is made to work because of proteins. If you want to know what they are as a chemist, they're a polymer. They're made up of building blocks. 20 different naturally occurring amino acids are the building blocks of proteins. And you can imagine when a protein is made, it's a linear polymer of amino acid 1, amino acid 2, amino acid 3, another amino acid 1, now amino acid 20, in a row in there. And the sequence of the protein is determined by the genes.
Now, you look at folding and misfolding. And as I say, I'm not a scientist. I used to be a journalist. So let me try a headline. What misfolding means is diseases including Alzheimer's and Parkinson's, but also cancers can be part of a consequence of misfolding. So just explain what, if you understand proteins and folding and misfolding, what does it help you understand about the human body and what goes wrong?
Okay. So I'm going to step back, like the good politician that you tried to interview when you was in the Today programme. I'm not going to answer your question directly. If we talk about biology, we're interested in information flow. So everybody here knows your genes are important. It's all in your genes. And the information flow is stored in your genes. Your genes tell the cells how to make a protein. They make that long protein, and then it folds to a specific shape that gives that protein the specific function. So, for instance, that bottle is made of glass, this glass is made of glass, but they're different shapes because they have different functions. The windows are made of the same substance, but they're a different shape as well. So, in many ways, in essence, I was just interested in how does the sequence of the protein decide what shape the protein will fold to. So, in many ways, the research I did was very fundamental. But what we know about biology is if a component is missing, the cell won't work. So when the protein has to fold to a particular shape, if it doesn't fold to that shape, the function will be completely missing. So one set of diseases, the consequences of proteins failing to fold properly, is just a loss of the function. So for instance, in cystic fibrosis, the protein fails to fold, and so the function of that protein is missing, which is why the fluid control in the lungs is completely missing.
I was going to say, so cystic fibrosis is obviously one case. This can be about pre-life as well as, some of the diseases we've talked about are obviously later life diseases, but misfolding has consequences at every stage of human life.
Yeah, and some failures of proteins to fold correctly because maybe of a mistake in the genes will actually lead to life never developing, being aborted in sort of before the baby's born. But then there are other diseases that you mentioned, like Alzheimer's and Parkinson's, and these diseases are really misfolding diseases because the protein doesn't just fail to fold to the shape it should be, it folds to a different shape which turns out to be toxic. So you've got the loss of function diseases, which tend to happen relatively early in life, although some cancers, which of course happen later in life, are also loss of function diseases. But then you've got the diseases which happen because you've got an accumulation of wrongly folded proteins, which ultimately could actually cause damage and then cause cell death, death of the neurons, loss of brain function, for instance, in Alzheimer's.
And just, I'm going to come on to your career in just a moment, but just so I understand what you do as opposed to what some of the other people in this room might do. If you identify what's happening, you are not yourself involved in, quote, cures for or seeking to medically ameliorate conditions, but you're looking at what's happening underneath the engine, as it were.
Yeah, I mean, I'm interested very fundamentally in, first of all, understanding how cells work normally. Because if you want to understand disease, you need to understand health. If you want to understand misfunction, you want to understand in the first place how it functions at the beginning, so you can understand the misfunction. But I think you'll find this, if you ask any basic scientist, I'm sure there are some in the room, that the fundamental understanding that we get from our basic sciences absolutely is essential to underpin all the discoveries that we then make going forward. So, a big call out to basic science. We need to do it because we'll never be able to do the difficult medicines, the difficult understanding how to cure disease unless we know how cells work in the first place.
Okay, we will come back to this. I can see quite a few scientists in the audience, so I'm sure they will have much better questions than I've had on that. But let's talk about you. So you come from a background of Welsh mining communities, but also from 3 or 4 generations of teachers. So tell us about that early bit of your life.
Yes, so I wrote an article for the chemistry department magazine, and it asked you about heroes and mentors, and it makes you really think about where you came from. And my mum was a scientist, and I think I owe everything I am really to my mum, who was a scientist, who taught me to be curious, and I never thought there was anything I couldn't do because she made me think I could. But she was the daughter of a Welsh miner who, for his 13th birthday, got 5 cigarettes and started down the mines. That was his birthday present. And I think it's very important, that Welshness, because the Welsh working class really, really believed in the power of education to change lives. And they were absolutely determined that their children would not have to live the lives that they did, and they recognised that education was the way to do it. So my mum was the first of all the families to go to university, and the rest of the family put everything they could into it to ensure that she could do it. They saw she had that potential and that she could do it. But you're right, her mother had been a teacher, and her mother before her had been a teacher, and of course they weren't qualified teachers, they didn't have degrees. These were sort of primary school teachers in the Victorian ages where you didn't have those, you didn't have those qualifications. But still, education, and it was all the women. The women did the education, the men went down the mines.
And you went to York University
Yep.
and did science, and so far so conventional.
So far, so conventional. And became a teacher. So far, so conventional. Well, because all the people that had got me where I had, all the people I admired were women scientists, Miss Smith. Do any of you? But Miss Smith, I grew up in Cambridge. I was town, not gowns. She taught us chemistry, and she was this amazing woman, and I wanted to do that.
So you became a teacher and worked at a range of schools and comprehensive schools in London.
Yeah, started in Leicestershire, in comprehensive Leicestershire. Then Chris, my husband, moved to London. We went to London, and I taught in Tottenham in Haringey. That's why I'm a Spurs fan. Sorry about that.
We'll forgive you that.
But taught in Tottenham. I was head of biology and then head of science there. When I had the children, went part-time and worked in many schools in Haringey. I watched Alexandra Palace burn down from my chemistry lab.
And when you were doing this, did you at that point think, actually, I want to be a university researcher and become a fellow of the Royal Society and a professor and all the things you did? Was that something that was remotely on your horizon when you were teaching in Haringey?
No, I was going to be head of a school. Lots of teachers don't want necessarily to be heads of department, but if you're head of department and then head of a school, you can influence the education of lots of children. So I was going to be head of a school. That was the plan. I actually had a place to study for a master's in education at the Institute for Education in London when Chris came home and said, shall we go to live in the States?
So that's what happened.
That's what happened.
Your husband got a job offer. Mm-hmm. And tell us what then transpired once you got to...
Well, it didn't matter that I'd had this. I thought, well, I could do this Masters in Education when I got to Atlanta. So I went to Atlanta, applied for Masters of Education, and I couldn't do that because I didn't have teaching qualifications, and I wasn't teaching in America. I didn't have college English and Georgia history. So I thought I'd just do a part-time master's course to update my science. So I went to Georgia Tech and enrolled in a master's course and had to do some research as part of that. Oh, wow, just fell in love with doing research. I hope those of you who do research get that. The trouble is if you're doing research here and you went straight on, you've no idea how exciting it is when you come back to it and you suddenly think, this is what I want to do.
Okay, so even so, you're then in your late 30s with children, and why then a PhD?
Because that's how you do research. One of the things I didn't do was plan my career at that point. I just knew I wanted to do research. And I didn't want to do somebody else's research. I wanted to do my own research. So you needed to get a PhD. And because by that time we'd moved out of London to Saffron Walden, which was on the Liverpool Street line, so Chris could get into the city. That was near Cambridge. So I decided to apply to do a PhD in Cambridge.
So you rock up as an intelligent woman, aged 40, wanting to do a PhD, and presumably Cambridge said, yes, come on in, we really want you, you start next week.
Yeah, presumably they did. No, they didn't. I just knew the vague area that I wanted to work in, which was this protein sequence to protein structure to protein function space that I talked about before. So I went to everybody in the biochemistry department that worked in that space, and they said, you're 40 years old, go away, don't bother us. One of them said, who would look after your children? None of your business. And he said, well, but I don't think it's possible to do a PhD and have children. So having got turned down there, the person at Georgia Tech who made me really, really interested in proteins had given me a letter for Alan Furst, who at that time had just come to Cambridge from Imperial. And he was the top protein chemist in the world. And so he said, I thought, well, I've been turned down by everybody else. So I cold called Alan. And he said, yep, start in October. And the rest is history, really.
I have heard you say, though, that you could only do it because you had a husband who, at that time, was earning enough money for you to be able to do that. So that was something which presumably was essential, because otherwise you wouldn't be able to afford to do it.
Oh, yeah. And that is the problem for I mean, you know, at the moment I'm at Wolfson College, which sort of specialises in mature students and returning to learning. And one of the problems for returning to learning is how people are going to be enabled to do that when now we know at the moment the current economic crisis, all families need 2 incomes to be able to pay the mortgage and pay the bills. So it is going to get harder to do that. And I think it's something that we need to be working with politicians to work out how we enable people at all ages and all stages and all different careers to re-enter education, because it's so powerful. But I couldn't have done it if Chris hadn't been earning enough for us to pay the bills.
I should have explained, I just looked at my phone, not being rude, but because that's the way, if you're at home, you can send in questions via master@sel.cam.ac.uk, and we'll also have some questions from the audience. But so when you do your PhD, it's one thing doing a PhD, which is great, but seeing a career and the kind of development in that career, when did that become apparent to you that was an option or something you wanted to do?
Well, I didn't want to stop. So I did my PhD and I didn't want to stop. So I applied for a training fellowship from the MRC to do biological NMR, which was also within Alan's empire. By then he had the Centre for Protein Engineering, and I had an empire, and so I stayed there. And one of the things that Alan was amazing about was he was encouraging me all the time to think of my own things. And one of the great advantages I had was I was sitting in the room next to Cyrus Chothia, so Jean's here, but the lab I was in was next to him, and he was an amazing person, one of the people that started this protein structure revolution. And he was always someone you could knock ideas around. And so I got an idea for some work I'd like to do, and I ran it by Alan, and he gave me a couple of students to try and get this work going. So I was doing a postdoc doing his work, and I had a couple of students, his students, working with me to get my own project going. And the most remarkable thing he did, when we got the first results, and I wrote up the paper, and I put the students, and then I put him there, and I put me as the final author, and he read it, he crossed it all out, he said, "You're Jane Clarke, not Jane Austen, stop being so flowery," with red pen, and did all that. And then he crossed his name out, and he said, "This will start your career." And that's extraordinary. Those of you who are in academia will understand just how extraordinary that is. I mean, I've known professors in the chemistry department who I reckon if you walk past their office holding your lab book, they want to be on your paper. And here was he giving me all the resources, paying me, paying the students, and saying this will start your career. And indeed it did.
I should say we have the head of chemistry here now as well. I saw it's just coming. So,
you
James
know
Keeler.
these people too, don't you?
So, Jane, apart from being 40, you're also, when you start your PhD, a woman in science. What special barriers were there to being a woman in science in that era? And I guess the issues have not gone away.
Yeah. Well, when I started my first group, I got a Wellcome Trust fellowship. Alan encouraged me and then gave me all the kit I needed so I could start off really well. I went back to the chemistry department because I had been Centre for Protein Engineering. And there were only, counting me, 3 women academics out of 50, 60 at that time. And I was the only mother. And there had never been a woman professor of chemistry at that time. So in 1997, only 3 women academics, and only one of them a mother, and no woman professor. So it was just lonely. It was just frankly lonely. My fellow early, new group leaders would go to the pub. I mean, famously, Shankar and Dave Krenneman went to the pub and discovered first-generation sequencing. If you're a mother, my husband earned all the money to fund us, but was never at home. So, in essence, during the week, I was a single parent, and I had to leave to go and do the mother thing. It was lonely. And things are better. Carol Robinson was the first woman professor of chemistry, then Claire Gray, then me. And it got better. But when Carol was elected Fellow of the Royal Society, the then head of department said, well, I know we always have a party, but actually it was so-and-so's turn, really, so we can't have a party. So, because you inferring that she only got it because she was a woman and they needed to appoint women. And that was not long ago.
It's a question which affects everybody about the extent to which they have a family life and a career and a range of interests and activities. But there's that horrible cliche about having it all. Is it possible to have it all, or are there things which you have to compromise with on the way?
Oh, of course it's not possible to have it all. I think you just have to decide which bits you want and which bits you're going to sacrifice. That's fine, but if you work in an environment which is hostile and thinks you can't really be serious about your science if you're not coming in on every weekend, and I know that the chemistry department is better now, but there was a time before Athena Swan when we were looking at it and we did a survey, and there were group leaders in chemistry then who were saying putting notes on the computers of their students saying, it's Saturday and Sunday, I've noticed you've not been in this weekend. So this inference that to live your life one way means you're not serious. The idea that there's only one way to be successful is a problem.
And how much has that changed in Cambridge?
I think it has absolutely changed, as in that would not happen, but it doesn't mean to say that people don't think that. I mean, nobody, I think, would dare put that notice on a postdoc's screen today, but it doesn't mean to say those same people are still around, and it doesn't mean to say they don't think it. There's nodding over there. And, of course, you can't be a perfect mother either. I mean, the day when I came home and David said, why aren't you a proper mummy? Was quite a difficult day. And I said, what do you mean? And he said, well, Debbie, that's his childminder, Debbie makes cakes. So you learn to buy cakes. Your children have to get used to having a bought costume instead of a beautifully handcrafted costume when they're in the school play. You can't be perfect, but you learn to be good enough and you learn to accept good enough. But then I think it makes you a better leader of people because you know they have lives too and you need to accept them to be good enough as well.
We started with age. You then, of course, came up to the mandatory retirement age in Cambridge of 67. So had we replaced sexism with ageism when we got to that point?
All isms are there. I voted for it. I know, and most academics voted for it, right? So it was popular. And I still am in favour of having a mandatory retirement age. Because if you think about my career, working with school children, working with brilliant students in the lab, working to support women in science and diversified careers in academia, I don't know an academic who thinks they're past it. I've never met one, and if we have, I'd like to meet that person. And unfortunately, we don't have infinite money, infinite positions, infinite lab space, infinite thing. And the people who are going to make the most difference are the people that are coming up. And of course it hurts. And the people it hurts are the experimental scientists. Because if you're doing English, if you're doing economics, if you're doing law, you can continue to do research without all the hassles of lectures and administration things. But it really, really hurts experimental scientists. So it hurts me, and I can't tell you how much I miss being a scientist. When I had, thinking about this tonight, and when you talk about things, I was at a symposium last week of women at the LMB. And it just makes me feel so jealous how much I miss doing that. But I still think it's right. Because there's something about intergenerational fairness. And that's fairness as well. So I still think it's right.
So do you think the people who keep going and keep researching and maybe even move universities to, because you can still get grants until you're 76, is that right?
I don't know what
Cambridge,
the current rules are,
but if you never thought of doing that?
Well, in the chemistry department, we had a very senior academic who got to the end of his time, and he was given a voluntary research extension, but it meant we couldn't appoint anybody to that named chair because there was no lab space to give that person. It's not just a question. I mean, like I said, I'd be really in favour of letting people continue for as long as they like, and historians do. But if there is a limited lab space, if there is limited grant money, scientists need loads of kit, loads of people, and it's the young people should get a chance. So, and I know I'm very unpopular.
I'm going to bring the audience in very soon indeed. But let's just sort of conclude the bit about your career. You ended as president of Wolfson College in Cambridge. And just tell us for a moment how being a mature college and how that also fits in with your vision of what kind of Cambridge you'd like to see developing.
Yeah. Well, it would never have occurred to me to apply to one of the traditional colleges to be master. We don't have separate spaces. We don't have a senior common room. We don't have a master's common room and a junior common room. We don't have a high table. We have married students. We've got our oldest undergraduates in their 60s. One of our current English students started at Wolfson when her youngest son started at Jesus because it was her turn to go to uni now as well. We have the largest number of part-time students of any college. We have over 300 part-time students who come in and upskill and upgrade while we're doing that. This returning to learning, we've got students from 96 different countries this year. Half the UN is in our college. And one of the things about modern research, you didn't give my full title, I don't want to complain, but my title was Professor of Molecular Biophysics in the Chemistry Department, which says everything you need to know about how multidisciplinary research is. And when you think about the problems the world has now, we don't just need scientists to solve climate change. We need people doing politics and economics and people that are good at communications and we've got somebody that I'm interviewing for a JRF tomorrow who's a psychologist and wants to look at what psychology of getting people to change their habits. We need people from every discipline to come together. And when I get new students in, I say that they could have gone to do chemistry in another good chemistry department. It wouldn't be as good as ours, but it would still be a good chemistry department. But if you come to a college, you come to a place where interdisciplinary conversations are almost mandatory because of what we do. We eat together, we sit together. And this is why the egalitarian, no high table, come to formal halls, sit next to somebody is wonderful. So it's my kind of place. And of course, they have a 7-year stint. They don't care how old you are when you start. It's a fixed term thing.
Okay, well, before the Selwyn Fellows go to high table, are there questions from the audience? And Chris down here has got the marvellous catch box, so can you signal if you want to ask a question, and we will throw a microphone in your direction. Can I also say, while we're doing that, if you are watching from home, master@sel.cam.ac.uk, master@sel.cam.ac.uk, and I will read out your question. Professor Grant Stewart.
Thanks very much, Jane. I'm a clinical academic and would like to echo your sentiments about basic scientists and give a shout out to them. In fact, we've just had some amazing research that colleagues of mine have done looking at kidney cancer and finding a protein that we can inhibit, and now we're going to set up a clinical trial in order to try and prevent kidney cancers from growing. But my question for you was an issue, or it may not be an issue or a problem, maybe it's an opportunity around that I'm seeing more and more, which is people in basic science postdocs, for example, but also now for the first time, clinical academics leaving the university and going to into industry, and this is happening more and more. So we have got an issue around talent retention that I think seems to be escalating. What do you think we can do differently to try and keep people within the university and develop their academic careers?
Well, for one thing, I don't think that going into industry is a bad thing. I mean, we can do the math. We get 300 PhD students in chemistry at any one time, and there are 60 academic posts, and those PhD students last for 3 to 4 years and the academics last for 30. So it's clearly they can't all stay in academic research. They can't even all stay in research. I mean, if some of our politicians had done research, we might be governed better, or we might have better science policy, say. I think academic careers, we've not got the career pipeline right. The pay is poor. I mean, you can earn so much more. When you teach an undergraduate here and they go and earn more than you do within 2 years of going to the city. I mean, people need to be able to afford to live in Cambridge, for instance. And I don't know any academics who, young academics who can do that now. I think we need to work at the career pathways. I think we need the postdoc time is particularly brutal when you've got these short contracts, and how we do that. But I don't think there's any political will to help that. And I think higher education is actually under severe pressure. It's such an easy target. I mean, if you got the Observer this weekend, the consultation about the congestion charge is town versus gown, according to the Observer. It's students and rich dons against the poor working man in Cambridge. Yeah. And that's from the Observer. So goodness knows what the Telegraph does. Said, but it's not easy. The grant funding situation at the moment is looking pretty grim. It's hard to get science is international. You know, I had students from all continents. We even collaborated with people working in the Antarctic. So 7 different continents doing research that was affecting our lab. And getting international people in, facilitating our students to go out into other labs and coming back. So of course we can't expect everybody to do it. And I don't think it's bad that great scientists are moving in. And I think we in academia need to be far more flexible about people coming back in. You've worked in industry, we'll welcome you back in as an academic. And having this flip to and fro. I worked on the protein polycystin 1. I solved the structure. Well, they've run these kidney proteins. So working with a kidney scientist, so, you know, this was cool too.
Fantastic, thank you.
A little bit of kidney knowledge there.
Okay. We'll come to more questions from the audience in a moment. We have a question from an alumnus online. In HE in the UK and other countries, there's a focus on publishing research papers and assessing impact as the most important measure of academic achievement. Is this fair to women who, regardless of ability, may simply have less time available for the cycle of research and publication? What alternative methods of assessment might be considered?
Good question. I mean, the way that we disseminate our research is through publication. So publication is important. There's no, I mean, you can't do research and then let people know what you've done, because all the work I did was paid for by the Wellcome Trust, a biomedical research charity. You had to get it out there. So publication is good. I would be in favour of a system where you ask people to give you their 3 best papers and you assess that. And these impact factors and things. It's not perfect. I don't know. I really don't know. I think we need to assess the science. I don't think you can blind assess it, because of course you know who's written the grant if you're involved in it, because you know they're working on work that they've already done and they're implying to do more. The answer is I don't know.
More questions, yes. Well, the catch-crops can go a whole one over there, and then we'll come down to Anna in front.
You've described an extraordinary career, and now on a very, very broad stage. Are there things you miss about school teaching?
I still go into schools. I still go into schools and I really enjoy it. I do love it. I'm not sorry not to be a teacher now, because schools have been so pinched for funding. When I was at Tottenham, we had so many technicians. We could do lab work all the time. We had plenty of resources to do lab work and the funds to do that. We had the freedom from a national curriculum. You know, you'd get a timetable and a bunch of kids that said by the end of the year they need to know this area of the curriculum. But you could use your creativity and your professionalism to decide what was the best way to teach that to this particular cohort of students. More and more, it's prescribed what you have to do. Science has become. When I was talking to, last week. I was talking to a group of students in Kent, and they think that science is all about facts. We know that science is all about not knowing things. But if you ask any non-scientists, they think science is all about knowing things. It's all about left-hand rule and right-hand rule and Ohm's law and Boyle's law and all these other things. It's all about laws and facts and things we know. Whereas we people that do science know that the joy of science is it's all about what we don't know. And it's when we get the best time in science is when you do an experiment and the result's wrong. So you throw it all away and you do it again, and you get the same wrong results. So you actually throw everything away and you order new cell lines and new chemicals and things, and you do it again. And when you get the same wrong result, it's the most exciting time in a scientist's life, because you realize that we've discovered something new, something that was not understood. And how we get that joy of not knowing into schools when they're so hemmed in, there is no space for just experiment. In schools now, if you want to be taught physics by a physicist, chemistry by a chemist, maths by a mathematician, your children to go to that school, they should go to a private school, a grammar school, or live in Cambridge, live in the southeast. My grandchildren live in Newcastle. And it's so unequal. But I could teach O-level physics. I did do O-level physics, but I was learning it from a book and, going through it. But as a physicist, you could teach it like a physicist thinks, not as facts. So I like going into schools. I love doing it. Over lockdown, I did some experiments, Zoom experiments with my grandchildren. My grandson flooded the kitchen, apparently, which I count as a real success. But I'm not sorry that I'm not teaching in a strapped, league table confined school system that we have now.
Okay, you rightly told me off earlier for not getting your title right, so I'm going to try to get the head of the School of Biological Sciences there, Anna Philpott, who is a Selwyn alumna and fellow of Clare. Anna.
So I just want to make a comment on what you said. One of the most depressing conversations I've ever had was I was at a sixth form event, and there was a girl there, and she said she didn't want to be a scientist because she wanted to do something creative. And I said, science is the most creative thing that you could possibly do. But she had been at school with the prescriptive stuff and not really doing any curiosity-driven stuff. So she thought that it was all about facts.
And it's teamwork. Not just creative, but you're working with people all the time.
Yeah.
I know.
But my question is, your children now, when they look back on it, do they still think your parenting skills were wanting, or do they actually think that it was fine?
I don't know. I'll ask them. Fortunately, the one thing I did, and I said this in the school there, the one thing that they hated me for, I made them do chemistry A-level. They wanted to do maths, they wanted to do biology, and then they wanted to do something else. Sports studies or... and I said, no, I don't care what else you do, but you're going to do chemistry. And Hannah wanted to be a lawyer, and David had no clue what he wanted to do, but it certainly wasn't anything that would involve chemistry. They're both medics now. And they couldn't have done it. They both went to university to do something else. Only 2 children, they went to 4 universities. But they wouldn't have been able to do that. And I think we shouldn't be letting... I go to schools, and schools saying to children, you should do the things that you like best. No, it's rubbish. You should do the things which keeps the door open. What you shouldn't allow our children to do is shut doors. And we let our children shut doors too often. I think they thank me, but I'll ask them.
Do signal if you want to come in with a question. I'm going to go to another online one. Dale Barton, who lives in Bingley in Yorkshire, Selwyn alumnus, says Selwyn admitted 9 students from the 5 northern counties last year, of whom 3 are women. It's probably a question more for me than for you, but I think you're answering questions. How do we get more women from the north of England especially to study science at Cambridge?
Well, I just inferred that they're probably not being taught but chemists by chemists and physics by physicists and this if they're in the state system in the north of England. I don't think. When I was at Trinity Hall as a fellow before I came here, we had real problem in attracting people from the north to Cambridge. I think the Cambridge. We need people in schools to tell students that they could go to Cambridge. I don't think it's something we can do. I think it's something that we need. We need to make people understand the opportunities that are available. And I don't necessarily think it's a Cambridge. I'm not necessarily sure it's our fault.
I'm going to answer a bit of this because for Dale and other people, we have appointed in the past year a new Northern Schools Liaison Officer, a very nice chap called Joe Stanley, who I saw in college today bringing a group of school children from Yorkshire around, and he is in the north the whole time doing that. So I think we recognise we've got to get a lot better at that.
I mean, one of the problems, is the most, believe it or not, as in the Royal Society, I have been part of their Equality and Diversity and also their Education Committee, reflecting my interests. And if you take groups who are underrepresented at higher education, first generation people, the first generations, will tend to want to do subjects which make them suitable for a good job. Particularly, when we went to university, it was free. They even paid us a grant to go. And now you're going to huge debt to go to university. And so, of course, you want to do a good job. And so people going into the sciences will tend to do pharmaceutical sciences, nursing, medicine, or they might do law. They won't do physics and chemistry because they don't actually understand that these degrees will suit them to do almost anything. But I think it's a problem in schools. I think we need to raise people's sights. The idea that, and this is under huge attack from both main political parties. Higher education's under attack. It's only of any use if we're producing the workers that the industry wants. And both sides think this, actually. Unless you're going to do PPE at Oxford and run the country, people despise the arts, almost. That's what you hear. I went to a Labour Party before the last election conference on post-16 education. I was the only representative there from higher education. Angela Rayner, who was then the shadow Secretary of State for Education, got up and she said, "I'm so proud my son isn't going to university." She should have got up and said, "My son's doing an apprenticeship and I'm so proud of him and that's a fantastic opportunity for him." I would have agreed with that. But when you get the Secretary of State, the potential Secretary of State for Education, standing up and saying that.
We've time for probably a couple more questions in the room.
It's more about politics than science.
Well, exactly. No, getting a bit political there. Signal if you'd like to come in with a question. Or if not, and Anna, you can have another go at bite of the cherry, yeah.
Are you now obsolete now we've got AlphaFold?
No, a really good question. I mean, AlphaFold's fantastic, isn't it? But I don't.
They don't know what AlphaFold is.
So AlphaFold is DeepMind, Google, and using AI to solve protein structures, and it is incredible. It can solve protein structures that haven't been known. I was at a meeting at the Royal Society night before last, and there was a protein crystallographer there who'd got the data, but they couldn't solve it, and it used AlphaFold to solve the structure of this crystal, of the structure for the data they have. But that's not the question I'm asking. This tells you what the structure is, but I'm asking, why does it go wrong sometimes? And most proteins, the active part of the proteins are very dynamic, and AlphaFold can't capture that. And in the last sort of 5 to 10 years of my research career, I started working on some proteins which, me having told you everything I've told you about how proteins have to fold to have the structure, there's a whole class of proteins that act because they are unfolded, intrinsically disordered proteins, which have a function because they are disordered. And we don't understand how can that be. And AlphaFold can't tell us anything about those. So it's just another tool in our toolbox. It will make it quicker to find new questions. That's why biology is the most exciting of sciences, I think, because every time you answer a question, it opens 5 more. So it is, because biology is driven by evolution, and it is clear that life is not designed because it is just bonkers. Biology does things in a way that you would never design it to do. You just wouldn't. And that's why when you discover something in biology, it's often something that you wouldn't have conceivably thought biology would work like that, and so that it opens more questions. But you absolutely need the tools of chemistry and physics to answer those molecular questions. That's why and that's why NatSci in Cambridge is such a great degree.
Okay.
It is the very best degree.
I'm going to ask a final question, which is 2 parts, I think. So, first of all, do you see yourself now as someone who was a mould breaker, someone who is a pioneer and broke down some conventions? And then following from that, whether you do or you don't, what is your advice to the next generation?
No. It's the first question. And it goes back again. It goes back again to my mum, who I never thought there was something I couldn't do if I put my mind to it. You know, you have to work hard, but you always have to take chances that are offered to you. And I don't like it when people say they're lucky. Women often ascribe their success to luck. I'm not a believer in that, although it's good to be lucky. But I was very fortunate having the parents I had and the background I had. Going to the school I went to, marrying a banker, having people like Alan Furst, who gave me those chances and who was so generous, give me a leg up, meeting people, wonderful people like Carol Robinson, Sheena Radford, Susan Markesy, who's in Berkeley, women who are my rivals, my supporters and mentors all the way through, and the amazing young people I work with. But I think my advice would be, don't let people say no. Just don't. I think you have to get tough. I think you cannot be an academic if you can't deal with rejection. Because you get rejected every single day. Your papers get rejected, your grants get rejected, you apply for jobs, you get rejected, your experiments don't work after three years and somebody else publishes it, or it all turns out to have been based on something that's wrong. But the whole thing is so much fun. So my advice would be determined, look for allies, don't let anybody tell you no. But looking for allies is important. Support people back and do what you love doing. And I know that was a privilege I had, that if you're economically disadvantaged, if you're a carer, all these things are more difficult. But being a scientist is so much. Now you've made me miss it again. Inviting me back again. Thank you, Roger, for doing that.
We will. And I mean, Jane, just huge thanks from me, and I know from looking at the expressions the audience do, and I'm sure people at home would join in. But thank you so much. That was inspiring,
Thank you.
Fascinating, and we're delighted you came to Selwyn tonight. Thank you very much indeed.
Thank you, Pat.
one quick commercial. If we're still online, I'm afraid this won't be available online, but on Saturday we have an event with West Streeting MP, who is Selwyn alumnus, former JCR president, and he will be talking at Selwyn on Saturday at 11:30 in the Chadwick room. So if you want to come, have a word with me afterwards, and we will look forward to that. But Jane, thanks again,
Thank you.
and thank you everybody for coming tonight. Really appreciate
Thank you
it.
very much. Thank you.